This was the part 1. There's a video of part 1. But this is part 1 of S4. We're talking about we were going in reverse. Example 1, we were showing what happens if we had a mu and a sigma and an area. How could we go back and find the value? And I showed you there were 2 different ways. Example number 2, if you wanted to know the top 20% and you're looking for the cutoff value on what the cutoff value of the top 20% would be, we said we had to do the area to the left, and we used all our official notation. So this is example 3, and this example is going to be one where we wouldn't have been able to use the calculator directly. So let's take a look at this one. Okay, so this one, example 3, is the heights of men are normally distributed with a mean of 68 inches if 20% of the men are taller than 70 inches, then what is the standard deviation? Now, if we had let our, I forgot the word standard. If we had just let our calculator do all of the problems on S3 and the beginning of S4, standard deviation, then we wouldn't have any skills and we wouldn't know how to do this one. So this one, I kind of think of it as works just like example 2. So what you do is you do the same thing to start with. You draw a picture because the picture gives you a lot of information. 20% is higher. We don't know the x mean. We do, 68. The z mean is always 0. And I'd like to know this value. And actually, they gave me that value. They said, this is 20%. And then they told me that 20% are above 70. So 70 is on your x-axis here for your normal distribution curve. So now it's asking for what's the standard deviation. So we need to know what sigma is. So if we try inverse normal on the calculator, we can't give it an a value. So we'd be stuck. But the way that I showed you, it's going to work the same way. So first thing is you can write the probability that x is greater than or equal to 70. It says taller, so we'll just use greater than. And that equals 0.20, which means the probability that z, okay, now we have a z that goes with the 70, so we'll just call that ZA and use our same notation. So the probability that ZA is less than, sorry about that, the probability that z is less than ZA is equal to 0.80. Let me write one step before that, because lots of people like to skip that ZZA step. So let's write it this way. X is less than 70 is 0.80. And if it makes you uncomfortable that it doesn't have an equal to sign, you can always add an equal to sign and it's the same thing. So at this point, you can, I'm going to skip a line because I'm going to show you the official way to write it. But you could write ZA is inverse normal of 0.80. That would be proper notation. So if you skip this middle step over here, because you can't remember exactly how to write it, that is okay. Because you do have the picture where you indicate what ZA is. So that would be the probability that Z is less than or equal to ZA. And you saw that I almost wrote the ZA in the wrong spot, so it is more unfamiliar. So it is important to write this step with the notation. Now we do our formula. So we do Z equals x minus mu over sigma. Now I have Z, Z is ZA. And it's some decimal, I don't know what it is, but it's some decimal that I'm going to store and then use. What else do I have? Well, I have mu. Mu is 68. But I have x. And then I'm missing sigma. Now, if I have those three variables and their numbers, and I need sigma, I think I could solve for that. So that's not going to be a problem. So let's substitute everything into the formula. So I really think of it as a conversion formula. It's basically a formula that converts between these four letters. So if you have two of them, then you can find the other two. Okay, so ZA, you can either write the decimal with a dot, 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 or you can just call it ZA, is X. So I look at the X number line for this, that's 70, minus my mu, which is 68, over my sigma. Sigma is the only thing I'm missing. So it looks funny. 2 over sigma equals ZA. But I can solve this. I'm going to solve this by cross multiplying. So ZA times sigma equals 2. And then I need to solve for sigma. So sigma equals, how to get rid of the ZA? You divide. And then I can find this answer on my calculator. So this answer directly, it looks like when I've done this problem before, I never actually typed in what this was. This up here that I just underlined in red. So I don't usually even find that out. You definitely can, and sometimes it helps you understand more. Does it make sense that it's positive? It's to the right of 0. Does it make sense that it's not? So that's up to you. But I just usually type it in directly. So this is 2.316. Supposedly, at least that's what I got in the year that I did these first notes. So I'm just looking at my old notes just to see. Let's see if that's what I got. Or I could just go to my calculator and see what it is. But you guys know, I don't always type the stuff in right in the calculator. So let's see. Well, it's not really showing it to me. I think that's a 2 point, but I can't tell if it's a 7. 2.316, 2.716, so I can't really tell. Okay. So let's do another problem. Okay, so let's do another problem. So the other problem is on a test. So this is, I think we're on example 4. Okay, so on a test, 10% of students score 93% or above. And the 30th percentile, so you gotta know what that is 58 points. Find what's missing. Let's see what's missing. I know what's missing, but let's see if you can figure it out. So we have our distribution. Sometimes when they give me two pieces of information, I like to draw it on different curves, but we'll see if we can see it in the same. 10% of the students score above 93. I think they don't have a percent here. Yeah, they just said 93. So 93 on a test. So, oops. So here's my line. So 93, so 10% score above 90. 93, excuse me. So 93, so this would be 93, and this would be 10%. So that's the area, or the percent. Okay, so that's the probability that X is greater than 93, and that's equal to 0.10. So I want to change it to a less than, or a less than or equal to 0.9, and then I need to do my inverse normal to find my Z-score. And again, this one is one that the calculator would not find you directly. So inverse normal of 0.90. So what's missing? So we'll see. We'll see in the formula. So the formula in here, put a little line here because we're going to do something on the right side of the line. So look at your formula. So you have Z equals X minus mu, and make sure you always write the formula first. That's communication. Make sure you're writing the formula. So I have ZA, and what's X? Well, X is 93. What'd they forget to give me? They forgot to give me mu. Did they give me sigma? They didn't. So the question is find mu mu, and sigma. So both of these letters, definitely the calculator cannot find this directly. So it's very interesting. Now this equation that I just wrote here at the bottom, right here, the ZA, I could cross multiply ZA times sigma equals 93 minus mu, at least to flatten it out, but you're still kind of stuck because you have two letters. ZA, we already know, because ZA is a number. So this is a number up here. So ZA is a number. So the only letters we're missing are sigma and mu. And so we kind of give up right there for a minute and we say, okay, well, did they give me any other information? So what else information did they give me? So let me do this one in blue so you can see it better. They said that the 30th percentile, okay, what does 30th percentile mean? So 30th percentile means 30% are at or below this value. So 58 being the 30th percentile means that 30%, so think of it like if you had the 98th percentile, that'd be really awesome, right? And in fact, this 93 is the 90th percentile because the area to the left is 90. Okay, so this is 0.30. And if both of them were to the left, I'd probably draw two separate pictures. So I'm going to put this in blue so you can see it. So the probability that x is less than or equal to 58, okay, and it doesn't really matter if it's a less than or an equal to or a less than in these problems, equals 0.30. You'll learn why in calculus. And then, oh, it already is a less than. So I can go right into ZA. Well, but I already have a ZA, so let me call this ZB. So ZB is the inverse normal of 0.30. And then that's a number. So you could get the number if you wanted, but you can't use it anyway. You'll have to store it because you don't want to use rounded answers in future parts of problems. Okay, so we write the formula again. I always write a formula right before I use it so they know what in the heck I'm talking about. So ZB is x. So what's the x of the blue one? So look at your x number line, look at your z number line. The x number line is 58. The mu, I don't know. The sigma, I don't know. ZB is just a number. I'm just keeping in ZB so that I don't have to write the decimal. And so I can keep it exact. So cross multiply, 58 minus mu. And then if you look, I have mu over here. I have sigma over here. What am I going to do? So what do you think? Let me write this again. So you have ZA sigma is 93 minus mu, and you have ZB sigma equals 58 minus mu. What does this remind you of? I think it feels like a system of equations. Now, what do you think? Should you solve this? What are your methods? So systems of equations, you've got graphing. Don't think I'm feeling graphing. What are your other two methods? One starts with an E, one starts with an S. What are the methods? So elimination, and what's the S one stand for? Substitution. Some people like substitution, some people like elimination in this problem. I like to use elimination actually. So I'll change this in red. I look, and if I line it up this way, the mu's almost cancel. But I need to change the signs. So I change the signs by multiplying by a -1 in the bottom. And then I work it out. So this one, they're not like terms. So ZA sigma minus ZB sigma equals, and then I work this out. So 5 borrow 3, 35. Now, I'm trying to solve for sigma, but there's two of them. And you'll learn this in calculus. Factoring out a letter can make one when you have two. In calculus, it's called implicit differentiation when we do that. That's how we solve it. If this step was really giving you some trouble, you could put the decimals in, and then you could subtract, but it gets pretty nasty. So it'd be better if you did this. And then I have to solve for sigma. Between the sigma and the ZA minus ZB is times, so you would divide. And then you'd get your answer. Now, to get your answer for sigma, what you'd have to do is you have to find ZA and ZB on the calculator. So how are you going to find ZA and ZB? So for ZA, you would do inverse norm. So inverse norm, and you would do inverse norm of 0.90. And then since I want z-scores, I would do 0 and 1. And then ZB, I would do inverse norm. And then what is the percentage to the left? It's 0.3. I would also write a 0 and a 1. If I was on an old calculator, I could leave off the 0 and the 1. But eventually, those of you with old calculators are probably going to get a new calculator. So it's probably best just to remember z's with z's, x's with x's. So right now I'm trying to find z's. This is calculator notation. So remember, when you're using calculator notation, you have an issue where not everyone always uses the same calculator. So sometimes the calculator notation is not appropriate for a college class. So you have to see, depending on the situation. Sometimes I like to see it just in case you make an error. I can figure out what error you made. Okay, so I typed these two into the calculator, the things I just wrote on the left. And then here I would type 35 divided by. I probably would store these. So I'd probably store this yellow one as A. And then I would store this bottom one as B, because there's not really a like ZA, ZB. And then I would subtract. Okay, now when I subtract, I get 19.380. I'm going to put ... because technically I would need to store this also. Now what should I store it as? Maybe you could store it as O, but you can store it as whatever you want. It is sigma. You can store it as S. Technically, sigma is an S. So whatever letter you want to store it, just write store so that I know that you didn't type in the decimals. And then you need to find the other letter. So I need to find mu. So how am I going to find mu? Well, do you have any equation that has two letters? So let me highlight this in blue for you. So if you can find, this one's kind of nice. This one has a mu and it's a positive mu. So I'm thinking I like that one. So down here at the bottom, or I could write it to the side. So over here I have negative ZB, which I have stored as B. Sigma, which I have stored as S, equals negative 58 plus mu. So add a 58 to both sides. And I get 58 minus ZB times sigma equals mu. So I got to kind of remember what I stored things as. So whatever I stored it as, you just have to remember. For me, it's nice if you write store so that I know you didn't use a rounded value. And then this is 68.163. And that is your mu. We'll put rounded, because you can round at the end. You just can't round in the middle. So I have the sigma, I have the mu, and I'm good. Now I could check my answer by going forward. Right, I have the sigma and the mu now, so I could check. So this would just be a check. I could do normal CDF. Remember, you do left first. So let's say, we're back to my picture, 93 to infinity. And then my mu, which is 68.163, I'm just checking, so I'm just writing the decimal in, comma, 19.380 is my sigma. And again, I'm writing those decimals in just because I'm checking. And this should give me approximately 10%, if it works. And then I would also check by doing normal CDF. Okay, left of 58. So 58's my right, so what's my left? So that's negative infinity. And that would be 68.163, comma, 19.380, and that should give me 30% if I did everything right. So this would be a way to check on the calculator, but the calculator won't directly give you mu and sigma. So it's kind of a very interesting problem. I like it. Okay, so that's why I wanted you to have experience with the Z method. Because if you don't have any experience with the Z method, it's just not going to make any sense. Okay, so let's see if I'm missing anything. We got that. We got this. Always draw a picture. It's going to definitely help you go backwards. We have that one. We have this one that we just did. This one's interesting. We're going to do a middle 80%, and it's called a confidence interval. So I'm going to do that as a different example. Example number 5. I'm going to have that separately. So I'm not sure if confidence intervals are in S4 or S5, but either way, it needs its own separate video. So this is the end of the main part of S4, which is just using inverse normal directly when there's no n value. Now, once you hit something with an n value, so I'll show you what's coming. So this is called confidence intervals. Okay, so confidence intervals. And confidence intervals, they're going to give you a percent. And what they want in the picture is they want 85% to be in the middle. And they want you to find what the values A and B are so that 85% is in the middle. But sometimes they give you an N. And this has to do with official statistics, where we're talking about sample spaces and populations. And when you're just collecting data from a sample, meaning you're not checking every single person or asking every single person, they have an N. So say N is 25, N is 100. That means how many people you would be asking. So say you were doing voting. Maybe you only asked 2,000 people and you want to know their opinion on the presidential election, and then you're going to draw conclusions from that. So things with N are going to have a new formula. So they're going to be very related. So you can tell this is going to look very close to the same as the one that we just did. We'll be able to find the A, we'll be able to find the B. Try to think of how you might do that. But we're going to have another formula. So the sigma of the X bars is called, sigma over the square root of n. So we use a new sigma instead of using the old sigma. And they will give you a sigma, and they'll give you a mu usually, not always. But it definitely depends on the situation. But usually in this case, they give you mu, they give you sigma, so they'll give you something here, they give you something here, they give you the n, and then this is the only difference of the thing that you have to do. So when you use your formula z equals x minus mu, those are all the same over sigma, but instead you're going to do z still, you're going to do x still, but instead of mu is kind of the same, it's called x bar when you're doing stats. X bar is for samples and mu is for populations. But we're not going to be too concerned with the theory. You'll learn that in AP Stats or in Stats in college. We're just going to be worried about the math operational aspect of it. So this one would be mu or X bar. And then this one we use that sigma over the square root of n instead of just regular sigma. So this will be a formula that you want to remember if there's an n in the problem. Okay, so if there's an n in the problem. But we'll do that in another video. This one's long enough, 22 minutes. Okay, sounds good. So we're still working on S4. The value of this is to have some expertise when you're in college, or if at some point you take AP Stats. We mostly concentrate on calculus. This confidence intervals, these are not in the IB at the moment, but they are changing the IB curriculum slightly. But I think it's still not in there. But we still wanted you to see it before all of a sudden you get to college stats and then you're like, what the heck is that? So we tried to help you with some things ahead of time. Anyway, so that's it. And I'll post another video on either the rest of S4 or on S5. I'll make sure that I check and get all this stuff for you.